Carrying on from my earlier tutorial regarding the charging of batteries from a vehicle's alternator using a split charge system, I am now going to discuss the charging of batteries, or to be more specific, the charging of a leisure battery or bank of leisure batteries using a B2B, that is, a battery to battery, or sometimes also referred to as a DC2DC, direct current to direct current, charging device. So what is a B2B or DC to DC charging device? It's similar to a split charge system, having a similar purpose, however doing it in a different and a more efficient way. This type of device, which in the course of this tutorial I will simply refer to from now on as a B2B charger, comes in varying different physical sizes, usually not a whole lot larger than a couple of stacked paperback books, and sometimes smaller, with varying power handling capabilities, 12 volt and 24 volts, and from 2 amps to 120 amps and possibly even more. And obviously there are a number of different brands and manufacturers out there on the market of varying quality. Don't just assume that the more expensive models are of better quality. Generally, what this device does is it takes the electricity generated by the vehicle's alternator, that is, the motor's electric generator, when the vehicle is running, that being the vehicle's excess electricity that is sent to the vehicle's starter battery, which is normally used to charge the starter battery, and it allows that same electric power to be further shared onto charging the leisure battery or leisure batteries. Generally, using a B2B device is a more efficient way than a split charge system that I referenced in my earlier split charge tutorial. However, when the motor is turned off, the B2B device isolates the leisure battery from any connection with the starter battery and its circuit or connection. So both batteries are then separated. You can then, without any worries, run down your leisure battery without further affecting your starter battery, like maybe by leaving a refrigerator turned on and forgetting about it, whilst leaving the vehicle standing for an extended length of time. I will point out that there are different voltages and different amperage rated B2B devices. For the sake of this tutorial, I will go with the most common configuration type and give you a few pointers as to what you might consider if you are thinking of fitting a B2B device. I'm going with a B2B device for this example that is rated at 12/12-18 isolated. So what does 12/12-18 isolated actually mean? Well, it's pretty easy actually. All B2B device manufacturers are going to have to inform you as to what amperage may be utilized by the B2B device, and also the voltages of the batteries or battery circuits that can connect to the B2B device. I strongly suggest double checking these important details with the manufacturer's supplied information, as these devices do come in a number of different configurations, not too difficult to understand once you grasp the concept. The first number 12 from the left, in this example 12/12-18, is related to the input voltage from the alternator that will come from the starter battery wiring circuit that is used for charging, which is often a nominal 12 volts. The second number 12 in the example indicates the voltage of the leisure battery to be charged, again a nominal 12 volts. The third number 18 in this example is the rate of current or amperage that the B2B device will push at the leisure battery, 18 amps of current. This would usually total 216 watts if you were to multiply 12 times 18 equals 216. See my earlier tutorial on DC electric basics. But it's not actually that important to understand watts in this instance. The model specifications literature have rounded the wattage off to 220 watts, close enough to 218 I guess. I have a starter motor battery that is rated at 12 volts, hence my motor's electric generating alternator and the vehicle's nominal system on the whole is rated at 12 volts. The term nominal means the standard voltage, used as a rough reference figure, as in we are roughly somewhere around the 12 volt mark on the starter battery system. Also, I wish to charge up a leisure battery or batteries that are again somewhere in the region of 12 volts. So the 12/12 indicates that both batteries or battery wiring circuits, starter and leisure, that this unit may be wired up to are both rated at a nominal 12 volts. Some B2B devices are rated differently and use different numbering formats, so be sure to check out their technical specifications before purchasing or utilizing a B2B device. But the documentation or labeling on a B2B device will always have to supply a notice as to the voltages and tolerances of what they might connect to and the amperage current that the B2B device can handle. A different example would be, let's say, a B2B device, that is, let's say 12/24-30. A device with figures like this associated with it would connect to a 12 volt starter battery and alternator circuit and feed a nominal 24 volt leisure battery circuit or bank of leisure batteries with a maximum charge rate or amperage current flow of 30 amps. Some people use groups of banks or batteries wired in series to give them a more powerful 24-volt leisure battery system. However, this is unusual, as most battery-powered leisure equipment is designed for just 12 volts. But you might note that some leisure battery-powered mobile refrigerators will indicate that they can work with anything between 12 and 24 volts. Be sure to check this. On the flip side, 24/12-30 would indicate that the alternator and starter battery bank in this case is a 24-volt system. This 24-volt system often being used on heavy-duty vehicles and trucks by combining two 12-volt heavy-duty starter batteries wired in series to total 24 volts, using the B2B device to charge a 12-volt leisure battery or battery bank at 30 amps. This is not altogether unusual electric system used on heavy-duty vehicles. Now, I should point out that some B2B devices can be connected to lower voltage rated battery systems, such as in the earlier example of 12/24-30, you might actually connect a 12-volt starter battery and a 12-volt leisure battery or batteries, and the B2B device will usually automatically sense that you are using a lower voltage battery than it was designed and rated for on its leisure battery connection, and the B2B device will automatically accommodate this. However, you should never try to connect a higher voltage battery system to a B2B device than what it was designed for. For example, you wouldn't connect a 24-volt starter battery and alternator system and a 12-volt leisure battery system to a 12/12-30 B2B device, as you can always go down in voltage on a B2B device, but not higher. So, a 24-volt starter battery and alternator system would be too high a voltage for this 12/12-30 model of B2B charging device. However, a 24/12-30 B2B device would be okay with a 12-volt starter and alternator system charging a 12-volt leisure battery system utilizing a 24/12-30 B2B device. Now, onto what isolated and what non-isolated means. Usually a term used in the B2B device description. This really isn't that complicated as soon as it's explained. On some vehicles, including boats, the bodywork of the vehicle is its ground circuit or earth bonding circuit, or you might think of it as the battery's negative connection. Usually the black negative wire from the battery will have a short wire or cable connection connected directly to the metal bodywork of the vehicle, making the metal bodywork of the vehicle simply an extension of the negative pole of the battery or batteries. That would be both the starter and leisure batteries will have their negative battery poles connected to the vehicle's bodywork. This is often called a grounded vehicle or an earth bonded vehicle, and is a cost-saving way of not having to run lots of individual earth or ground wires through the vehicle. It is fairly common for vehicles to be grounded or earth bonded in this way. This type of vehicle could use a non-isolated B2B device with no problems. Alternatively, on a vehicle that does not use its bodywork as a common shared negative or negative connection ultimately to the battery's negative poles, a physical ground or negative wire or cable will have to be used from each and every device needing a negative battery connection, and that negative wire or cable will need to be run all the way back to the battery negative pole, or alternatively to what might be called a negative bus or ground hub, which is just a central meeting point of all the negative or ground wires that pertain to all the varying vehicle electric devices that need a negative battery connection. That bus or hub will in turn have a heavier gauge wire that runs to the negative pole of the batteries. Some vehicles cannot use their bodywork as a common ground for a number of reasons, possibly because the battery systems used for their starter battery and their leisure batteries are of a different voltage, or the bodywork is not a metallic electric conducting material, or if it's a boat due to something that is called galvanic reaction. This type of vehicle would need an isolated B2B device, isolating the ground or earth connections from one battery and the other, or one 12-volt circuit and 24-volt circuit, or for any number of reasons as explained earlier. An isolated or non-isolated B2B device. A non-isolated B2B device usually has just three heavier wire or cable gauge screw-down terminals. 1. A plus positive red terminal used to connect to the starter positive plus battery circuit. 2. A negative black terminal used to connect to a common ground, earth negative, usually the vehicle's bodywork. 3. A positive red terminal used to connect to the leisure battery, positive battery circuit. There may also be some smaller screw-down terminals for connecting temperature sensors and other special switches. I will discuss that later. So that leaves us with what an isolated B2B device actually is. An isolated B2B device usually has 4 heavier wire or cable gauge screw-down terminals. 1. A positive red terminal used to connect to the starter positive battery circuit or battery terminal. 2. A negative terminal used to connect to the starter negative battery circuit or battery terminal. 3. Negative terminal used to connect to the leisure negative battery circuit or battery terminal. 4. A positive red terminal used to connect to the leisure battery or positive battery circuit or battery terminal. There may also be some smaller screw-down terminals for connecting temperature sensors and other special switches. I will discuss these later. The isolated B2B device type is designed to circumvent the 2 negative circuits sharing the same negative or earth or ground connection, should this be desired or required. This is usually when the bodywork of the vehicle cannot be used as a common ground, earth, or negative connection. Maybe the bodywork is a non-electric conducting material, like fiberglass or wood, or there is some other reason that the earth-ground negative wires should not be connected, possibly due to different voltages being used by the starter battery and the leisure battery. However, in some cases, if you happen to have a B2B device that is designed for isolated earth, ground, or negative connections, and there is no real need to isolate the earth, ground, negative connections or circuits, then it will do no harm to the B2B device to connect the 2 earth, ground negatives on the B2B device to a common earth, ground, negative bus, like the metal bodywork of a vehicle. Bus just means a common connection, an earth or ground or negative, or usually the black or negative wires from both the starter and leisure batteries, connect to the same common terminal or conducting material, such as the bodywork of a metal vehicle. So in short, you can use an isolated B2B device in either a metal conductive grounded bodywork or earth bonded vehicle, or a vehicle that does not use its metal bodywork as an earth, ground, or negative battery connection. Or there are different voltage batteries being used for the starter and leisure batteries. It covers all bases. However, a non-isolated B2B device is designed for use on a vehicle that has no problem with both the starter and leisure battery circuits sharing the same earth, ground, or negative battery connection. Both starter and leisure battery circuits and systems are using the same voltage, and the metal bodywork of the vehicle is being used as a common earth, ground, or negative battery connection. Now on to the amperage or amps factor here. This is something that has to be seriously considered. If you're using a B2B device to charge a lead-acid battery or bank of batteries, then this will probably not apply so much to you, as lead-acid batteries can handle fairly high amperage charge rates without too much of an issue. However, if you're using a lithium-ion battery or batteries, then the amount of electric amperage charge that is pushed at them needs to be smartly moderated. Check my earlier tutorial on lithium-ion batteries. They can be sensitive as to how you charge them. Check the battery's manufacturer's specifications on how much amperage might be sent to the battery. These specifications are usually often given in a battery shorthand description called the C rate or C factor. The C rating used in batteries is kind of like a decimal notation method, indicating a percentage of the manufacturer's full rated value for the battery, applied to both its charge and discharge limits. Sounds complicated, but it's actually not that complicated as soon as it's explained. For example, in a 100 amp lithium-ion battery, 0.2 C maximum charge would mean 1/5 of the battery's amperage capacity. In this 100 amp example, that would be 20 amps. 0.5 C maximum charge would mean 1/2 of the battery's amperage capacity, that being 50 amps. And 1.0 C maximum charge would mean 1/2 of the battery's amperage capacity, 100 amps. So it might be charged with a 100 amp charge. The C rate is kind of like giving a decimal division of a battery's percentage as a whole. Sound complicated? Not really. So 0.2 C is 1/5 of 1. So 1/5 of the 100 amp 12 volt battery would equal 20 amps, as 1/5 of 100 is 20. So this would indicate the maximum charge rate of a 0.2 C rated maximum charge battery. So you wouldn't want to use a B2B charger that pushed more than 20 amps or was rated at higher than 20 amps. If you had two 100 amp batteries wired in parallel, therefore giving you the equivalent of a 200 amp 12 volt battery, then you might be able to push 40 amps at 12 nominal volts at them. Keep in mind that some brands of B2B device will allow you to configure or certainly reduce their rated amperage rate via their software, meaning your phone might be able to log into them via Bluetooth and you can reduce their rated amperage from, let's say, the stated 30 amps down to 18 amps or whatever amperage you feel is safest. Hope you can grasp this. You might go over it a few more times if you can't. Quick explanation of batteries wired in series or in parallel. Series means that the batteries are wired with one positive battery pole connected to the other's negative battery pole. This doubles the voltage, however maintains the same amperage as a single battery, e.g. 2 times 100 amp 12 volt batteries wired in series 2 times 12 volts equals 24 volts, yet still it would only have the same 100 amps of flow regardless of its doubling of voltage. However, if you were to wire both the negative poles of the batteries together and the two positive poles together, then that would keep the two batteries at 12 volts, yet the amperage would double. 2 times 12 volts equals 12 volts at 200 amps. So it depends on how your battery banks are wired together. If you are combining or banking more than one battery, it will change or multiply either their voltage or amperage. But combining batteries doesn't boost both voltage and amperage. It either boosts the voltage or the amperage depending on how they're wired. What is better? It all depends on your needs and the equipment that you need your power to supply. A little more on lithium C ratings and their discharge rates and abilities. Don't get this mixed up with charge rates. Always be sure to check lithium-ion leisure batteries specifications before connecting them up. If you, let's say, had a nominal 12-volt lithium-ion battery that was rated at 100 amps, however, its technical profile suggested that it could dish out or discharge a maximum of 2C for a few minutes, then it might drop down to 1C after a minute or two. Then that would mean it could give a boost of up to 200 amps for just a few minutes, then drop down to its regular rated 100 amps or 1C after those couple of minutes. This is handy for some motorized devices like some refrigerator compressors that when they first start up their compressor cycle, they demand a lot more amperage, impulse current, or amps for the first few seconds, and then drop down to a lower amperage, more continuous and consistent demand for the rest of their cycle. There are other devices that need an initial boost of power to get started, so that power surge, impulse current, can be handled for a minute or so over the nominal stipulated continuous and constant 1C rating of the battery. If the lithium-ion battery specifications suggest that it should be charged at no higher rate than 0.2C up to its recommended 100 amp capacity, then you should use a B2B charging device rated at no higher than 0.2C or 1/5 of its rated power of 100 amps. That in this case would be 20 amps. And if the B2B device is configurable, as many of them are, you should set it for a lithium-ion battery charge profile, as this will charge the lithium-ion battery in a specific way, automatically, taking voltage and amperage into account, using what is called bulk charging, up to 80% of its charge capacity, then slowing down the rate of charge, lowering the amperage, to what's called absorption charge, up to 99%. There is no need for a trickle or float charge, as is used with lead-acid batteries. This charging process is usually built into and computer-controlled on most decent quality B2B chargers. If you're charging a lead-acid battery or batteries, then you would set the profile to lead-acid, as lead-acid batteries have their own charging methods and profiles. Note, the B2B device might need to know what type of lead-acid battery you're using. AGM, absorbed glass mat, gel or gelled acid, or liquid, flooded acid. The battery type should be stated on the battery label. Some lithium-ion batteries can handle a significantly higher rate of charge. However, you will find that most B2B chargers developed for vehicle use don't go much higher than 120 amps. The average amperage charge rate of B2B chargers being around 30 to 40 amps. Note, again, the wiring, the physical terminal connections, and the battery itself can get hot whilst charging. If anything is getting hot, then you should inspect the wiring, the physical terminal connections, and the battery for poor connections. If the connections are all good, clean, and solid, then you should seriously consider reducing the amperage being sent by your B2B device to your leisure battery or circuit until you come down to a point where the leisure battery or batteries and their connections are not getting hot or more than lukewarm. My personal rate for B2B charging for my 100 amp hour 12 volt lithium ion battery as a benchmark being 18 amps, as I have found that the battery cells can get a little warm when I go over 20 amps. As it is, I am fortunate to be able to monitor the leisure battery cell temperatures on my battery system. Heat is never a good thing for batteries and can be quite destructive and degrading to lithium batteries, so I try to keep the batteries charging temperatures fairly stable and not a lot higher than lukewarm. So how do we wire up a B2B or DC to DC charging device? Usually they are pretty easy to wire in. Always keep the electric wire or cable gauge in mind. Make sure you're using the correct gauge of wire or cable. There are plenty of DC, direct current wire gauge calculators out there on the internet. Keep in mind the length of your wire when calculating also. See my earlier tutorial on electric wiring. Just as an example, or a benchmark, here's what I use on my 12-volt 100-amp lithium-ion battery setup, charged from a medium-sized 1.9-litre VW T5 campervan's alternator. I use a 12/12-18 B2B charging device. That is an 18-amp rated B2B device that can connect to a 12-volt starter battery circuit and a 12-volt leisure battery circuit. As I know the lithium-ion battery cells get warm if I go over 20 amps in charge. That would be 0.2C in lithium-ion battery terminology. Also, what should be taken into account is the extra strain and demands being made on the vehicle's alternator, which can also get hot, more so if the vehicle is sitting stationary and the engine is running and the lithium battery is fairly empty and needs a significant amount of charge, like it's 60% or more empty. We don't want to burn out the alternator, which can happen unless you have an industrial rated alternator designed for high power demands. So finding a balance between your vehicle's alternator's capabilities and your battery system's safe demands will give you an idea as to what amperage rate your B2B device might be set for. Watch out for anything getting hotter than, say, 100 Fahrenheit or 37 centigrade. My system, just as an example, the wire from my starter battery to my B2B device is less than 3 feet or 1 meter long, and as it won't be loaded with any more than 18 amps at 12 to 14 volts, as my 18 amp B2B device will be the bottleneck or 18 amp restriction, limiting the electric current amperage being sent through the wire cable, then a 5.2mm squared or AWG10 American wire grade wire cable is almost overkill, as it is able to carry 120 amps over 6 feet or 2 meters. I'm going to be moving at most, as I said, 18 amps through the leisure battery cable or wire from the starter battery to the B2B and from the B2B to the leisure battery at most. It was, at the time of my fitting my B2B, an adequately rated wire or cable that I had on hand, and it's not a problem using a heavier gauge or wire or cable, but you should never use a wire or cable gauge that is too light to handle the power travelling through it. Don't use household domestic AC wiring unless you know exactly what you're doing and what it might be rated at in the DC electrical world. Just because it can handle a higher AC voltage doesn't mean it can handle high amperage DC electricity. I also cannot overemphasize the importance of using fuses or circuit breakers. Always base the fuse or circuit breaker rating on the weakest link in the chain, that normally being the wiring. However, in my above example, due to the fact that the B2B device is only rated at 18 amps and the wiring at 120 amps, then a fuse or circuit breaker of 18 to 20 amps would be the most sensible option. Again, in my case, my 18 amp B2B device is the limiting factor on the power being sent from the vehicle alternator starter battery circuit to the leisure battery circuit. A fuse on both the positive red wire or plus wires running to the B2B device, one fuse or circuit breaker on the red cable wire running from the starter battery circuit to the B2B device, and another fuse or circuit breaker on the cable wire that runs from the B2B device to the leisure battery circuit. Note, on some B2B or DC2DC devices that have a smart alternator or an ignition live wire small screw down wire terminal connection, sometimes also referred to as the D+ alternator signal, designed for the more modern eco-friendly vehicles, that being on vehicles that shut the engine down when the vehicle is sitting stationary, this small terminal wire is used to signal to the B2B device if the motor is running or not. The idea being you have to send a small amount of 12-volt DC electricity to this screw down terminal and the cable wire connected to it to turn on the B2B charger, and when the vehicle alternator is not running, therefore not generating any electric power, then the B2B charger is then turned off, as there is no electric power going down this small wire, and therefore the starter and leisure batteries are then disconnected and isolated by the B2B device. This smart alternator or an ignition live wire from the small screw down terminal wire connection you might connect to a piggybacked fuse in the common fuse box. The fuse you connect to must be in a circuit that only comes on when the alternator is running and generating power. Some people just connect it to a fuse that comes on when the ignition switch is turned on, not necessarily when the engine is running. I personally disagree with this way of connecting the smart alternator or an ignition live wire. I would look for a fuse to piggyback onto. You might find some videos or tutorials on piggyback fuses on the internet. If I am wiring up a B2B, that should come into play only when the motor is actually running and the alternator is generating power. This can be tricky finding a fuse that only has power passing through it when the engine is running, but it can be done. I will make another tutorial on this. As it is, some people part turn on their ignition to keep on the parking lights or the radio or entertainment system, but they don't start the engine. In this case, there would be no need to also turn on the B2B device, as the engine is not running, so therefore the alternator is not generating power. This is why piggybacking onto the right fuse is important. Alternatively, many B2B devices are activated when the voltage created by the alternator on the starter battery circuit is pushed up to 13.2 plus volts by the engine running and the alternator creating electric power. And alternatively, the B2B is shut off when the voltage drops below 13.2 volts, therefore isolating the two battery circuits. When the motor and alternator is stopped and the starter battery circuit voltage drops back down to its resting voltage of less than 13.2 volts, usually around 12.6 volts. So there isn't always a need to connect a small smart alternator or ignition live wire. Two other small screw down wire or cable terminal connections you might find on a B2B device are more often than not thermostat wire connections. The thermostat sensor wire that usually looks just like a single looped wire with double naked metal wire ends, which will probably come in the box with your B2B device. Those two naked wire ends will connect to two of the smaller screw down terminals on the B2B device. Doesn't matter which way round the wires connect to the terminals, as long as both of the wire ends or cable ends are connected into the B2B thermostat screw down terminal connections. And the other end of the wire is taped to or attached to the battery. Its job is to monitor the battery temperature. It's not really an electrical conductor as such. The wire itself, though it's insulating through its insulating sheath, can sense changes in temperature at the end of its length through a looped sensor. If the battery gets too hot, the B2B sensor will shut down the B2B device. Incidentally, you will connect it to your leisure battery, not the starter battery. It connects to the leisure battery. So as you can see, there are a number of different ways or triggers that the B2B device might use in order to switch on or off, connecting or disconnecting the starter and leisure battery circuits. Note, it is always better to keep your B2B device somewhere close to your leisure battery. The shorter the wires, the better. But if you have to run a long length of wire, be sure that its gauge is thick enough to carry the estimated power in the way of current. Hopefully this helps you understand what a B2B device is and how it's used.